Today. Yeah, everything so far is fine. I don't know. The only thing I'm not sure about if how I did the LPO is that how SWOT wants. I mean, so you just send him the list, no? You send him the list, no, whatever the pending LPOs, and like what do you call? No, not that.
Hello, am I audible? Can you hear me?
Yes, yes.
So he wanted me to he wanted me to cash like manual POs for those, no? Because I think this owning company is making drama. They wanted with LPO.
Hello, can you hear me?
Yes, audible.
Okay. Okay. Hi. So let me start. So otherwise we will wait for 2 more minutes and start the class. Oh. Hi. Hello. Okay, so I will be starting now. So last class, what I have taught you is a basics of thermodynamics. So today, what I will be doing is I will be going some deeper into some of the laws of thermodynamics. Before that, some of you will be new to the class. So what I will do is I will give you a brief about what I have taught you in the last class. Okay, that PPT is already shared. Okay, I will just show you. So last class, first thing what you have studied was what was thermodynamics. So what was the definition? Basically, what we see about thermodynamics is the energy transformation. Okay, or what you can see, any turbine, any pump, or anything, what we see, there is some energy transaction. Okay, that basics what we are studying in thermodynamics. So the science of energy that concerned with the ways in which energy is stored within a body is known as thermodynamics. That was the basic thing we have studied. And this energy transformation means energy can be in the form of heat, work, depending upon anything. It can be energy can be in the form of heat or work. So how it is transformed in a system, or how it is stored in a system, or how energy is conserved, that are the basic things what we study in thermodynamics. Basically, the next thing in thermodynamics is what I have taught you in the last class is system, surrounding, and boundary. Okay, you may know when you are studying about a thermodynamic thing, the first thing what you have to know about is system. System is what? The quantity of matter what we are chosen for study. That was our system, and the outside the system it is known as surroundings, and system and surrounding is what separated by a imaginary point which is known as its boundary. Okay, it can be real or imaginary. This is what we have studied about system surroundings and boundary. Then we have studied about some of the, it will not transfer any mass or energy around the body. Okay, whatever isolated system means, it will not transfer any mass or energy to the atmosphere. That type of system is known as isolated system. For example, means if you are having a thermoflask, that is an example of an isolated system. That is an example of an isolated system. Then the next is closed system. So in a closed system, the energy can cross the selected boundary. That type of system is known as closed system. So for example, when closed system is there, if you are, for example, if you are keeping a coffee in a tightly capped cup, okay, what happens? Energy will cross the boundary. Okay, that amount of coffee will be kept over there, but the hotness of the coffee may reduce by time. That is known as closed system. But isolated system, it will not happen. Whatever heat and energy is there, it will be there in the system itself. Okay, that type of system is known as isolated system. Closed system means what happens? Energy can cross the selected boundary. That type of system is known as closed system. Open system means both energy and mass transfer will happen. That type of system is known as open system. So these are the basic things what we have studied in the last class. Then what we have studied, the properties of the system. So the properties are classified actually into two types. One is known as intensive property and another one is known as extensive property. So the properties which are independent of the mass are known as its intensive property, and which varies directly with mass are known as extensive property. The example are temperature, pressure, and density are the examples of intensive property, which varies directly with the mass. Example are mass, volume, energy, enthalpy. These are the things what we have discussed in the last class. Then we have gone about specific properties. Specific property means the ratio of any extensive property of a system to its mass gives you specific properties. Then state, equilibrium, and process. That is what equilibrium means. I have told you in the last class itself, there are three types of equilibrium. One is thermal, mechanical, and chemical equilibrium. A body, when we can say a body is in equilibrium, means it should have to obey these three equilibrium. One is mechanical, thermal, and chemical. Mechanical means when a system is in equilibrium, it will not apply any external force, or it will not be having any external force. That means the system will be in mechanically equilibrium. Chemical equilibrium means there will not be any chemical reaction happening. Then thermal equilibrium means there will not be any temperature change. That is what. When a system is in equilibrium means it will be having all the three conditions, that is thermal, chemical, and mechanical equilibrium. Then we have studied about types of thermodynamic process. In that, one is cyclic process. That means when a system will be starting from an initial state, it will undergo through various process, and finally when it will return to its initial state itself, that process is known as cyclic process. Okay, that means if it is starting from 1 and it is passing through different processes, example 1 to 2, again comes to 1 and the process stops, that type of process is known as cyclic process. Okay, then reversible process means anything process which can be reversed. Okay, so that type of system is known as reversible process. Irreversible process means we cannot reverse a process. Okay, it will be happening only on one side. Okay, we cannot reverse that process. That type of process is known as irreversible process. Then there are known as adiabatic process. Adiabatic process means there is no heat transfer. Then isentropic process means entropy is constant. Polytropic means it is a reversible process. PV raised to N is a constant. Okay. Then throttling process means there is no change in enthalpy. Then we have studied process. Then thermodynamic equilibrium I already explained. Then the next thing what you have studied is there are laws of thermodynamics. In that last class I have explained up to first law of thermodynamics. So I will give you what I mean by zeroth law. Zeroth law is the basic law of thermodynamics whose application is using to find the temperature. Okay, so the thermometer is an example for zeroth law of thermodynamics. Okay, that means the law states that when two bodies are each in thermal equilibrium with a third body, they also remain in thermal equilibrium with each other. For example, A and B are in thermal equilibrium, then B and C are in thermal equilibrium, then A and C will be in thermal equilibrium. Okay, this was the basics for temperature measurement. So this zeroth law of thermodynamics gives the basic idea for measurement of temperature. Okay, this was we have studied in the last class. Then first law of thermodynamics. So basically the first law of thermodynamics states that energy conservation, that energy can neither be created nor be destroyed, but it can be changed from one form to another. That was the basics of first law of thermodynamics. Okay, so we also say law of conservation of energy also we may say like that. Okay, so we can see that when it is applied to a cyclic process, delta Q cyclic integral of delta Q minus delta W is equal to 0 gives the idea of first law of thermodynamics. So up to this we have studied in the last class, that is first law of thermodynamics. Okay, now today what we are going to study is the thermodynamics has two more laws. One is second law of thermodynamics and another one is third law of thermodynamics. Then this second law of thermodynamics actually has two statements. One is Kelvin-Planck statement and another one is Cauchy statement. So the specialty of this second law of thermodynamics is that, for example, heat engine, etc. works with the help of this second law of thermodynamics. For example, Carnot cycle, etc. Every cycle what we study is the basics of this second law of thermodynamics. So we will be starting from second law of thermodynamics. So second law of thermodynamics, there are two statements. One is Kelvin-Planck statement and another one is Cauchy statement. So just I will read this statement. After that, I have got another PPT. Through that PPT, I will explain all those things. What is this, etc. The first statement is that it is impossible for an heat engine to produce a net work in a complete cycle if it exchanges heat only with bodies at a single fixed temperature. That means the simple basic is that if an engine has to work, it has got two temperatures. That is the basics of this Kelvin-Planck statement that I will explain how it is happening. Everything I will explain. Then it is next is Cauchy statement.
Should be
Cauchy statement.
don't
Hello?
eat.
Sorry, sir.
Okay. Cauchy statement. So Cauchy statement states that it is impossible to construct a device operating in a cycle that can transfer heat from a colder body to a warmer one without consuming any work. Also, energy will not flow spontaneously from a low temperature object to a higher temperature object. That means we cannot transfer a temperature from a that means energy from a low temperature reservoir to high temperature reservoir. If it has to happen, we have to apply some work. Okay, for example, the energy can transfer from a high temperature body to low temperature body without any application of work. Why it is happening? It is happening because of this temperature difference. But when in case of low temperature, when you have to transfer an energy from low temperature to next higher temperature, we cannot do like that. We have to apply work for that. Okay, so This is the basics of this Cauchy statement. So these are the two statements. Now I may be using some other PPT for explaining all those things. What is second law? How? What do you mean by Cauchy statement, Kelvin-Plan statement, and what is the functionality of all those things? Okay, let me wait. First, let me close this PPT. So I think and another PPT is visible to you, no?
Yeah.
So this is, so when you say about this first and zeroth law, they are very simple to explain. So zeroth law, we have know that if there are three bodies, if they are in thermal equilibrium with each other, so the if of 1 and 2 are in thermal equilibrium, 2 and 3 are in thermal equilibrium, then 1 and 3 will be in thermal equilibrium. Also, the first law of thermodynamics is law of conservation of energy. So that is the thing, that two are very simple statements. But when it comes to second law of thermodynamics, there are some more problems why we are explaining this with the helps of these two laws. First thing is that, so in this thing, you have to see it identifies the direction of process. That is the first important thing in second law of thermodynamics. Okay, that means, for example, heat. What happens if you are keeping a hot tea open to atmosphere? What happens? Heat will transfer from this hot tea to atmosphere. Why it is happening? It will happen spontaneously. Why? Because there is a temperature difference. Okay, no? Okay, no? So there is a temperature difference. So heat will spontaneously transfer from a hot object to cold object. But if it will not happen, that means if there is no temperature difference, that means vice versa. That means it is very difficult to transfer heat from a cold object to hot object without application of any work. Okay, that is what. Identify the direction of process. That means heat can spontaneously transfer from a hot body to cold body. Why it is happening? Because of the temperature difference. Okay, that is the first thing. That is the importance of second law of thermodynamics. Next is used to determine the quality of energy. Quality of energy means, quality means, you may see a high temperature energy source. If energy source is having high temperature, it is said to be having higher quality because it is easier to extract energy and deliver it to useful work. Okay, because a high temperature energy source has a high quality, so it's easier to extract energy to deliver it to useful work. Okay, I think some of your Zoom meeting is not muted. Okay, please mute it. Okay, please mute. All of you, please mute. Otherwise, it will be difficult for me to interact with you. Okay, please mute the class. Next is, it is used to determine the quality of energy. Quality of energy means high temperature energy source is having higher quality. Okay, so quality means it is easier to extract energy and deliver it to useful work. That is a specialty of this higher quality energy source. Okay, higher quality means, that means the energy will be very easy to extract energy from an higher source. That is what it is known as quality of energy. Okay, then next is possibility of constructing 100% efficient heat engine and perpetual motion machines. So that means, I have told you already Kelvin plans and Cauchy statement. Okay, so 100% efficient engine means what is the specialty? You may know it. It will be having no losses. But when you consider your vehicle, for example, when you're considering your vehicle, for example, your bike, what is specialty of this bike? It will be having so many moving parts, mechanical parts. We also provide lubrication. Why we are providing lubrication? In the sense, lubrication is provided because to reduce the friction. So what does that mean? There is already a friction aspect in the engine. Okay, friction means whatever work we are giving or the energy we are giving, it will not be converted into work. Some will be lost due to friction. So it means that it will not be possible to construct an 100% efficient engine. We are saying that Carnot is an 100% efficient engine, but it is not possible because losses are there. Okay, that is what the third point explains. Used to exclude the possibility of constructing an 100% efficient heat engine and perpetual motion machine. Then you use the concept of reversible and irreversibility. That means I told you some of the process are reversible process, and the process which are not reversible are called irreversibility. So these two terms, okay, what we study, these two concepts what we study is the basics of second law of thermodynamics. Okay, then this second law of thermodynamics is the basic core theoretical performance limit of engineering system. That means heat engine or whatever practical engine is there, the main calculation of efficiency is based on second law of thermodynamics. Okay, a Carnot engine is theoretically the most efficient heat engine. Its performance can be used as the standard for other practical engines. So since Carnot engine is the most efficient engine, heat engine what we have, that is why on the basis of Carnot cycle only we are doing or we are using other standard practical engines. Okay, so that is what Carnot engine is theoretically most efficient engine. Okay, Carnot is a theoretically most efficient heat engine and its performance can be used as a standard for other practical engines. Okay, that is the importance of this one. Okay, next slide. Okay, next is second law, the continuation. So you may see this figure. So this is an heat engine. So heat engine, there is TH and there is TL. Okay, what is H? Hot body, and TL is the cold body. Okay, the device which that converts heat into work operating in a cycle, okay, is known as what? Heat engine. What is the specialty of a heat engine? Heat engine is a device which converts heat into work while operating in a cycle. That is known as heat engine. So you can see over here, this is the hot body and this is the cold body. Okay. So we are heat engine is doing a work. That work is termed as W net. Okay, W net. W net is QH, heat of cold body minus, sorry, hot body minus heat of cold body, QH minus QL. Okay, that is W net. W net is work done. So work done, there is a heat transfer QH to the system. There is a heat loss to the system, that is QL. So if this is a hot body and this is a cold body, there will be heat transfer from the hot body to the cold body. Okay, so from the hot body, QH heat is transferred and from the hot body, QL heat is transferred. So work done is QH minus QL. So what will be the efficiency of the system? Work done, net to work divided by heat extracted. Okay, QH. What is work done? QH minus QL divided by QH. So when you divide it, you will get 1 minus QL divided by QH. Okay, this is the efficiency. Okay, so this is the about heat engine. So you have to understand that heat engine, there is a hot body and below there is a cold body. Sorry, and there is a hot body and below there is a cold body. In between an engine is connected. So from the hot body, QH will be extracted and some work will be done by the heat engine. That work is known as W net. After that work, it is going to heat is going to the cold body. Okay, so that is TL or QL what we represent here. So the net work done is QH minus QL. So efficiency is W net divided by heat extracted. So that is QH. So when you W net equation, we already know QH minus QL divided by QH. So the efficiency is 1 minus QL divided by QH. Okay. So we cannot produce an 100% efficient engine. I have told you in the beginning itself. Why? Because there will be heat losses in the system. Okay, heat losses or energy losses. Why heat loss or energy losses is happening? Heat losses and energy losses are happening because of friction and other complications in the moving parts. Okay, is it clear for you? I think this much is clear.
Yes, sir. Yes.
Okay. In doubt? Any questions?
No, sir. No.
Okay, thank you. So when you comes to this power plant, so we have already discussed about heat engine. So for an heat engine, the best example is steam power plant. So what is the specialty of a steam power plant? Actually, the steam power plant, the main specialty is that it will be producing steam. Okay, what is specialty of steam power plant? It will be producing steam. Then what is the reason for this heat engine? What is the working fluid in the steam power plant? Anybody working fluid? Anybody, can you say? Some of you will be working in a steam power plant. So what will be the working fluid? It will be water. Okay, this water will be converted into steam by when it undergoes some thermodynamic cycle. Okay, this steam power plant is a good example of heat engine where the working fluid is what? Water, which undergoes a thermodynamic cycle. Okay, so in the last session itself, we have told you W net is equal to W out minus W in, also Q in minus Q out. Okay, that means this I will explain how it is coming. You may see here, there is a pump over here. You can see this process. A pump is there. When we apply, for example, we are having a centrifugal pump at our home. For example, pump at our home. So in order to work this pump, we have to switch on the motor. Is it clear? So we are doing a work on the pump. Okay, when we do this work, what happens? Water will be transferred from pump to boiler. Okay, no? When we start this pump, when we are doing some work on the pump, whatever water present in the surface, whatever it may be, it will be transferred through pump to the boiler. Okay. In boiler, we will be applying heat. When we apply heat, what happens? The water will become steam. Okay. Is it clear? I think it's clear. Okay. So
Yes.
after the steam is produced, the steam is used, turbine will be working, and this W Okay, sorry. Okay, sorry, there is rain over here. That is what, there is some issue. Okay, sorry for that. Okay, the power is fluctuating due to rain. Okay, so this is the working of a steam power plant. Okay, I think it's clear for you. I will explain it once again. So if this is a pump, when we do work on the pump will transfer water to the boiler. The boiler, when we supply heat to the boiler, whatever water present in the boiler will become steam, and this steam will be the input to the turbine. So this turbine will be doing some work, and this is the work output, and whatever water will be left or the steam will be left, it will be passed through the condenser, where we will be condensing it to again water, and again it will be going through the pump, and pump will again transfer this to this boiler, and again turbine, then condenser, etc. Okay, so this is a cyclic process. Okay, so this is an example of heat engine. Okay, so the next work done is work output minus work input. Okay, work input is happening in which sun? Pump, and work output is happening in turbine. Okay, no? Okay, so
Yes, clear.
so this is what we have done. So the thermal efficiency is work net divided by heat extracted. Okay, the equation will be same only. Okay, so the typically the efficiency of steam power plant is 40%. Then the next thing what we are going to study is thermal reservoir. Actually, what is thermal reservoir? The example of a thermal reservoir is atmosphere. Is a thermal reservoir. Large lakes, oceans are examples of thermal reservoir. Okay. So that means it will be having very large capacity. Okay. So this is the example of thermal reservoir. Next. So I have in the first, during the starting of the section, I have explained Kelvin Planck statement, but now I'll explain. Now you have got some idea about this heat engine, etc. Okay, now I will be giving you what is Kelvin Planck statement. It is impossible for any device that operating on a cycle to receive heat from a single reservoir and produce net work. For example, when we see a steam engine, there were what a pump was there. For example, I will be writing here, pump was there, boiler is there. Then what was there here? Turbine was there, and again condenser was there, again pump was there. Okay, so if we apply, if it is impossible for any device that operate on a cycle to receive heat from a single reservoir. So here we are having different reservoirs. Then only what happens? There is a work. Okay, that is what the first, second law of thermodynamics or the Kelvin Planck statement is all about. Okay. So this statement is without proof. However, it has not been validated yet because it is impossible to build a heat engine that is 100%. For example, what they have done is, there is a heat engine over here, you can see. So we are applying this is a hot body, and we are applying a Q to heat engine. If total W net, whatever Q we are supplied, it will be transferred to work. Okay, then it violates which law? Kelvin Planck statement. Kelvin Planck statement says that if there is a hot body, and if you are transferring a heat or energy to this heat engine, some will be transferred to work and some energy will be liberated to atmosphere or cold body, whatever it may be. Okay, so it will not be possible to work with a single engine, okay, or a single reservoir. There will be more reservoirs for energy transfer to happen. That means it is impossible to build a heat engine that is 100% efficient. That is what it is. That is what the proof of Kelvin plant statement. Okay, so that means if we are having an heat engine, for example, if you are having a heat engine over here, that means heat engine is there. Okay, if it is connected to hot body, this is hot body over here, this will be cold body, then Q will be liberated from the hot body and some work will be done by the heat engine and some heat will be liberated to cold body. Okay, this is the procedure of a heat engine. Okay, so this is what happens. If this cold body is there, it will become 100% efficient, but it is not possible. Okay. Okay, I think it's clear. Kelvin plant statement. Next is heat pump and refrigerator. Okay, so these are the basic devices for heat transfer. Okay. So what is the function of a heat pump? Heat pump is defined as a device that transfers heat from a lower temperature source to a higher temperature one. That is specialty of heat pump. Example, heat pumps are used to extract energy from outside cold outdoor air into warm indoors. Okay, that is the specialty of this heat pump. But refrigerator is that a refrigerator performs the same function. Difference between two is that heat transfer that need to be optimized. That means in refrigerator, what happening? It will be cooling the air. Okay, that is a function of a refrigerator. But heat pump, it will be heating the room. For example, when we are using a heat pump in a room, it will be heating the room, while refrigerator, it will be cooling the room. Okay, so both of this refrigerator and heat pump are the examples of some heat transfer devices or application of first law of thermodynamics. Is it clear? I think it's clear for you. Next is heat pump or refrigerator. The specialty is that we have to do some work on the system. Then only it will be doing. For example, if we are extracting heat from a cold body, then we will be doing some work on it. Then only it will be transferred to hot body. Okay. Okay. So for example, heat pump and refrigerator. What is how a refrigerator is functioning? If you are keeping an apple in a refrigerator, for example, if you are keeping an apple in a refrigerator, what happens? So there will be a refrigerant which will be transferring through the refrigerator. Okay. So this refrigerant will take the heat from the apple. For example, if you are keeping an apple. So the apple will be kept at a temperature below the atmospheric temperature. Okay. So this heat will be taken by the refrigerant. It will, what happens? What happens when a system absorbs the heat? What happens? It will convert into a vapor form. Okay. And it will again transfer through evaporator, absorber, etc. and again come as liquid form, again come through the inside the refrigerator. Again, if whatever food we will be keeping, it will be absorbing the heat from that body. Again, it will become vapor form, and again it will also absorb, and it will again become fluid, and it will again extract heat. Okay, so whatever is there, we have to do a work on the system to do this. Okay, so that is what, for an heat pump or refrigerator, you have to do work on the system, then only some heat will be, or some amount of heat will be extracted and transferred to hot body. Okay, this is what. Okay, no, refrigerator, function of a refrigerator. So this refrigerator and heat pump comes in Cauchy statement. So what do you mean by Cauchy statement? It is impossible to construct a device that operate in a cycle and produce no effect other than transfer of heat from a lower temperature body to higher temperature body. That means without, I have told you, without the application of any work here, we cannot transfer heat from a cold body to hot body. But we can transfer heat from hot body to cold body directly. Why? Because of temperature difference. But we cannot transfer heat from a cold body to hot body without any external work. That is the statement of Clausius. Okay. Heat cannot transfer from a low temperature to higher temperature unless external work is supplied. Okay. So whatever heat is there, if it is to be transferred from a low temperature body to higher temperature body, what happens? Some external work we have to apply. Okay. That means if you are building a refrigerator or heat pump, refrigerator or heat pump, okay, we have to give some external work input. Then only this refrigerator or heat pump will work. Otherwise, it will not work. Definitely, we have to provide some external work input. That is what Cauchy statement gives you. Cauchy statement states that it is impossible to construct a device that operate in a cycle and produce no effect other than transfer of heat from lower temperature body to higher temperature body. Okay, so that is specialty. You have to be very specific with the statement. It is impossible. It is not possible to construct a device that operate in a cycle produce no effect other than transfer of heat from a lower temperature body to a higher temperature body. So if you have to transfer heat from a lower temperature body or a higher temperature body, there should be some work input. So this is the example of this gives the example of heat pump, refrigerator, etc. For a heat pump, refrigerator, whatever is there, we have to apply some external work. Then only this will function. Okay, so the statement is that it is impossible to construct a device that operate in a cycle and produce no effect other than transfer of heat from a lower temperature body to a higher temperature body. So heat cannot transfer from a lower temperature higher body unless external work is applied. That is the meaning of this statement. And the thing is that if there is heat pump or a refrigerator, we have seen this, whatever is there, if there is a heat pump or a refrigerator, it should have some external work input for working. Okay, because we cannot transfer heat from a lower temperature body to higher temperature body without the application of any work. Okay, that is what Cauchy statement is done. Okay. So equivalency of two statements. That means that this equivalency of two statement means that if we violate any one of the statement, violation of one of the statement, it will lead to violation of the other statement. So that means they both are equivalent. Okay, that means if you are without the application of heat, if you are transferring heat from work, if you are without the application of any external work, without the application of any external work, if you are transferring heat from a cold body to hot body, okay, that is the violation of which statement? Cauchy's statement. Okay, so what happens? It will, if we violate this statement, it will automatically violate which one? Kelvin-Planck's statement. Okay, that is a specialty. What is Kelvin-Planck statement? If you are having a single reservoir and whatever heat we are supplying, it will be converted into work. It will not be possible. Okay, there will be some losses. Okay, that was our thing. Okay, if we are violating this Kelvin-Planck statement, the engine will be 100% efficient. Okay, this is not possible. Okay, so heat transfer from a lower temperature body to higher temperature body without work is the violation of Cauchy's statement. Okay, so if you violate Cauchy's statement, it will automatically violate Kelvin-Planck statement, and if you violate Kelvin-Planck statement, it will automatically violate Cauchy's statement. So I have to be specific with these two statements. Kelvin-Plan statement, if you violate Kelvin-Plan statement, it will automatically violate Cauchy's statement. And if you violate Cauchy's statement, it will automatically violate Kelvin-Plan's statement. Okay.
Okay, sir.
So perpetual motion machines. I think this is not possible because PMM1, you may see here, PMM1. This is perpetual motion machine of first kind. Okay, that means if you violate first law of thermodynamics, first law of thermodynamics, first law, violate first law of thermodynamics. Okay, that type of machine is known as perpetual motion machine. What is that first law? Energy can neither be created nor be restored, but it can be transferred from one form to another. That is one PMM1. Okay, so what is PMM2? PMM2 means when we violate second law of thermodynamics, it becomes PMM2. That is perpetual motion machine of second kind. But this is also not possible. So PMM1 is the violation of first law of thermodynamics. PMM2 is the violation of second law of thermodynamics. Okay, you may understand that PMM1 and PMM2 are not possible. Okay, because energy can neither be created nor be destroyed, but it can be transferred from one form to another. Similarly, we have told you if there should be some heat transfer from a cold body to hot body, we have to apply some work. Okay. Okay, no, I think it's clear.
Yes, sir. Yes, sir. Clear.
Yes, yes, it is clear.
So next is reversible and irreversible process. So a reversible process is one that can be executed in the reverse direction with no net change in the system or surroundings. Okay, actually you have to understand one thing. No real processes are reversible because there will be some frictional changes or frictional losses happening in the system. So no real processes are reversible. So what we see theoretically only we can say it's a reversible process. So whatever when you see actually whatever process is there, it is not reversible. Okay. So reversible process will not be happen because what is the reason why reversible process is not possible? The main reason one is friction, sudden expansion and compression, heat transfer between the bodies within the finite temperature. Okay. So these are the reasons why the reasons why the system, the process are not reversible. Okay, there will be friction, there will be sudden expansion and compression, also heat transfer, bodies between finite temperature difference. Okay, so example of a reversible process is quasi-static process. That is the best example for a reversible process. What you say, it is a quasi-static process is a example for reversible process. So quasi-static process means, for example, if you are having a, I will just see here, I'll draw here. If you are having a system, this is the condition 1 and this is the condition 2. Okay, if you are keeping a 10 kg weight in P1, okay, if this condition is P1, it will go to P2. Okay, so if you have a graph, this is P1 and this is P2. So if you draw this, you will get a graph like this, 1 to 2. I think it's clear. Because at one first point, the piston was at P1. And when we have kept this 10 kg over here, the piston moved to condition 2. Is it clear? This is what happening. So if you are converting this into courses, this is an example only. Okay. This is this why I am explaining it so that you can understand it. That is why. If you are dividing this 10 kg into 1 kg of 10 bars. Okay. So that means first we are keeping it in, first we are having a piston, and this is the point one. First we are keeping 1 kg. So it will move to downward direction. So it will become equilibrium. Then we are keeping the next one. So it will again move to downward direction and it will become equilibrium. That means when this 10 kg was kept at once, we are dividing this 10 kg into 1 kg of 10 bars. And in each condition, it is approaching to equilibrium state. So there will be so many equilibrium state over here. There will be 10 equilibrium state over here. So what do you mean by quasi-static process? It is a process which is done in infinitely small step. Whatever small step possible, if you are doing that process, infinitely small step, and in each step, the equilibrium is achieved. That type of process is known as quasi-static process. And the example for a reversible process is what? Quasi-static process. You have to understand that quasi-static process is a process which is done in infinitely small step, very, very small step you have to do. Okay. In each step, what is a specialty? It has to reach an equilibrium state. Okay, it's clear. It has to reach an equilibrium state in each process, and then only the next process will be happening. So when it is moving from 1 to A, for example, 1 to A, for example, if you say it has to move from 1 to 2 actually. So we are having different state over here, A, B, C, etc. So when it comes to A, it will become equilibrium. Then only it will be A to B will be happening. Then B to C will be happening. Like that, every process will be done in infinitely small step. And in each step, what is the specialty? An equilibrium state will be reached. That type of process is known as quasi-static process. So it's an example for a quasi-static process, reversible process, but we can say it only theoretically. Practically, reversible process is not possible because there will be frictional losses, sudden expansion losses, and also heat transfer. Is it clear for you? Okay. So one of the ideal cycle which employs this reversible process is Carnot cycle. This is also theoretical cycle. In practical session, we cannot have Carnot cycle. Okay. Okay. So I think it's clear for you, all the things. So we will wind
Yes,
up
sir,
the
yes.
session for today. It is already 9:30. Okay, no? It's clear for you, no?
Yes, it's clear. Say, just a question. Did you say
Ah.
the PPT was shared already?
PPT?
Yes, the PowerPoint presentation.
Yes, sir. Yeah, yes, Mr. Yeah, we have already shared the class. Once the class was finished, the next week itself, we have shared the PPT.
Okay,
If you want it, I can share it
Okay.
once more.
Okay. All right. Thank you.
Okay.
Okay, thank you. Okay, thank you.
Thank you so much.
Okay, thank you. Okay, so I think we shall wind up. Okay, good night.